In this part, we are going to write a system of equations to be able to solve this word problem. So let's take a look at it. It says it takes Ted 10 minutes to make a black and white drawing and 25 minutes to make a color drawing. On Friday, he made a total of 9 drawings, and it took him 2 hours. Write and solve a system of equations to determine the number of drawings. Well, let's take a look at our unknowns. Here's one of them right here. Black and white drawings. How many did he end up drawing? We don't know. So we'll call the number of black and white drawings, why don't we call that W? We don't know how many that is, so we'll just use the variable W because a B might look too much like a 6. The other unknown is the color drawings. So why don't we say the number of color drawings equals C for color. So now what we're going to do is we're going to set up 2 different equations. We've got what we call a quantity equation, and the quantity equation is the number of drawings they made, or Ted made in this case. So we don't know the number of black and white drawings. We don't know the number of color drawings, but if we add those 2 numbers together, we do know that number is 9 because he made 9 drawings, it says. Now the value equation. Typically a value equation is going to deal with money, but in this case we don't have money, but we do have hours and time is valuable to us, so I'm still going to stick with calling this a value equation. Well, it took Ted 10 minutes to make a black and white drawing. So let's do this. Let's take the number of black and white drawings, W, and multiply it by 10 minutes. That'll give us the total time he spent on just black and white drawings. Now, let's add in the time it takes him for color drawings. Color drawings are 25 minutes. So let's go ahead and multiply the number of color drawings by 25, and that will give us the total time for just color drawings. And now that's going to equal the total amount of time, which is 2 hours. The problem is that we can't use 2 hours because hours are a different unit of time than minutes, and we need the same unit of time. So we're going to have to convert 2 hours to minutes. So we're going to multiply by 60 minutes per hour, and then we can get those hours to cancel. So that's going to be 120 minutes. So we've got to use 120, and that's the mistake most people will make on this type of problem. Well, from this point, we can go ahead and solve it. I'm going to use the elimination method. Now, when I look at this, I think I'm going to multiply by negative 10. It's easier than multiplying by a negative 25. See, if I want to cancel out the W's, that's all I'd have to multiply by. And multiplying by a 10 just adds a 0 to the number. So negative 10W minus 10C, and this equals negative 90. And so now we can go ahead and add these equations together, and it will cancel out our W term, leaving us only with our C term, which would be positive 15C, and this will all equal 30. Well, we just go ahead and do that one final step. That'll tell us the number of colored pictures, and that's to divide by 15. So we go ahead and do that, and now we've got C equaling 2. C equals 2. So that's the number of colored pictures that Ted ended up drawing. Well, to find the number of black and white pictures, all we have to do is substitute right back into that quantity equation. That's the easiest one. And so it's W plus 2 equals 9. Well, we go ahead and subtract the 2 from all sides, and we've got the number of black and white pictures. He did a whole lot of black and white pictures, not too many colored pictures. But there's how we do it. Well, let's take a look at the next type of problem. These two are going to have different types of answers, and they call these special systems because they don't have the typical one answer that we usually would have. Well, on this first problem, it's not really set up for elimination. It's more set up for substitution because we've got a variable solved for, except that the variable has a coefficient in front of it. Well, looking at these two, which would be the best to solve for? Well, if we divided by 2 here to get y by itself, we'd end up with fractions because we'd have to divide this number by 2 and this number by 2. So let's go ahead and get rid of this 3, because when we divide by 3, we end up not having to deal with any fractions. So let's go ahead and rewrite what we've got right down below, and it's going to be x equals negative 2y plus 1. Well, now this problem is set up for substitution. So let's go ahead and do that. We're going to take this negative 2y plus 1, and I'm going to put it in place of that x in the equation above. So when I do that, what I've got here is a 2y equals the opposite because that minus sign in front of the x, opposite of what x is, negative 2y plus 1. And then I have to bring down that other plus 1. Let's bring that down into the equation as well. Well, from this point, we can go ahead and take the opposite of these numbers. Remember, the opposite's like multiplying by negative 1. And so when we do that, we now have 2y equals, and then a positive 2y minus 1 plus 1. So we go ahead and do a little bit more work there, and we might subtract this 2y from both sides, and we end up with something that we haven't seen, at least in this section, before. We have seen this before in problems where we've just been solving with one unknown, though, when we end up canceling out the variable. See here, that makes 0. But when we combine these two, we also get the same number. 1 minus 1 makes 0 as well. So what we said before was that all real numbers was the answer, and that's one way we can say it. All real numbers, and that includes any number on the number line and numbers in between. But there's also another way to say this, and since we're dealing with lines, the reason why we have the same number, they equal, is because they are the same exact line. And that means that we have every point on that line as a solution. So since we're dealing with points as solutions, we also treat this as, we say, instead of all real numbers, there's infinitely many solutions. And that's another way they represent the answer when we have a number equaling the same number and your variables cancel. So it's only when the variables cancel. A lot of people will get confused because they'll get 5y equals 0, and then they'll say, oh, it must be infinitely many solutions. No, it's only when the variables cancel. All the variables are gone. There's no more variables anymore. 2y minus 2y makes 0, and the other number's exactly the same. That's when we say infinitely many solutions. It means that we have the same exact line. These two lines are the same. Well, here's another example, and this one is already set up for substitution. So let's go ahead and do it. Negative 4x plus 2, that goes in for that y down below. And we go ahead and rewrite what we've got. We've got a 4x plus, but in place of this y, we're going to write the expression y is negative 4x plus 2. And this all equals negative 2. Well, when we go ahead and do the work, we combine some like terms on the same side of the equal sign. We got a 4x and a negative 4x. Uh-oh, we're getting those to cancel again. Remember, if they're the same number but opposite signs, it makes 0. So now we have 0 plus 2, which is just 2. And 2 does not equal negative 2. And so we've got a different situation here. Since these two numbers do not equal, we say that there is no solution. That's one way we can say it. Another way we can say it is that these are parallel lines. Parallel lines will never end up crossing, or they do not, and when I say they, the lines do not intersect. And so when we're dealing with lines that are parallel, if you look at a parallel lines are going together. They're always going up a certain way, and they'll just never cross. They'll never get any closer together. And so that's why there's no solution, because a solution is where they cross. Well, if we have the same line, if we draw one line right there, and we draw another line right on top of it, there's infinitely many solutions. See, these lines, all the points that make up both lines are exactly the same because they line up right on top of each other. So that's why we say there's infinitely many solutions when they're the same line. Parallel lines, there's no solution. So whenever the variables cancel, you're either going to have infinitely many, which means that we have the same numbers equaling, or they're not going to equal, in which we say there's no solution, or parallel lines. Well, that is part 2 of this lesson.